Okay, so yesterday, Cole and Connor taught you guys how to use the molarity equation to solve for molarity. Well, we could also use the same equation to solve for the number of moles or for the volume, so we don't just have to solve for molarity. Okay, so example 3. How many moles of solute are present in 1.5 liters of 0.70 molar sodium hypochlorite? Okay, so again, our equation is molarity is equal to moles over liters, and we are solving for how many moles. So what I'm going to do is I'm going to plug an X in for moles so that we know to solve for it. Okay, and we know that we have our liters and we know that we have our molarity. So 0.70 molar equals X, remember X stands for moles, over 1.5 liters. So we're going to multiply both sides by 1.5 so that those cancel. And when you do that, you get X to be in sig figs 1.05, and don't forget it's moles. So 1.05 moles is our final answer. Okay, so it's just a little bit of algebra moving things around. All right, so moving on. Example 4. How many moles are in a 335 milliliter sample, I guess, of 0.425 molar ammonium nitrate? Again, we have our equation. We want moles, so we're going to replace that with X and solve for it. Our volume is in milliliters. So like Cole told us yesterday, if you need to get it to liters, you move your decimal 3 times. So we're going to go 1, 2, 3. So that is equal to 0.335 liters. All right, of a molar solution. So plugging in our stuff, 0.425 m equals X over 0.335 liters. Multiply both sides. And X, our moles, is equal to 0.142 moles. Okay, so those are easy. Now, we can actually figure out how many grams as well. Once we know the moles of the solute, so once we solve for X, then we can actually take it one step further by finding the mass using molar mass. So this skill we need for our lab on Just Kidding Monday. We're making some Kool-Aid. Okay, so we're going to solve for X and then use molar mass to get to the grams of our solute. Okay? So example 5. What's the mass of calcium chloride that's in a 250 milliliter sample of 2.0 molar solution? Okay, so we want to know grams at the end. We know that we have 250 milliliters, but remember, we need liters. So we're going to move our decimal 3 times to the left. So that is equal to 0.250 liters. And we know it's 2 molar for the molarity. So our equation to start, molarity equals moles over liters. Plug in what we know. We're going to stick X for moles, because remember, first thing to do is solve for those moles. And then on the bottom, put our volume, the 0.250 liters. So let's go ahead and multiply both sides by 0.25. And we get our number of moles to be 0.50 moles. Okay, but that's not what we need. We need the mass. So now, once we got step 1 taken care of, now we're going to go from moles to mass, to grams. So if you need to look at your mole map, you can. But what we're going to do is we are going to multiply by the molar mass of calcium chloride. So we need to know what the formula is first for calcium chloride. Well, that is CaCl2, because there's a +2 charge on your calcium. And when you look up the numbers from the periodic table and multiply that out, you should get very close to 115.609 grams per mole as your molar mass. Okay, so on the mole map, it tells us to take what we know over 1. So we're going to take the 0.50 moles over 1 times, and we're going to put grams on top. So the molar mass goes on top, 115.609 grams over 1 mole. The moles cancel out. We're left with grams, so we can go ahead and solve. So when you multiply those two numbers together, incorrect significant figures, you get 58 grams. So, to review, you need your mole map, you need your periodic table, and you can do this. Solve for moles first, and then plug it in to your equation. Okay, so now we can finish up the molarity homework packet after watching this.
I'd like to make myself believe that planet Earth